All right, so in this final example, we have x's on both sides of the equation, but it's fine because we can just subtract that x squared over. So if we simplify this, we'll get x cubed minus x squared is less than or equal to 0. And now this is an inequality we know how to deal with. Let's factor. We'll end up with x squared times x minus 1. We want that to be less than or equal to 0. So we know that this is equal to 0 at x equals 0 and x equals 1. So let's go ahead and make our sign chart. Right, so we have x squared, which is always non-negative, x minus 1, and our cut points are 0 and 1. And then our whole function is x cubed minus x squared, and that's what we really want to know about. So when x is less than 0, x squared is still positive. When x is greater than 0, x squared is still positive. So x squared is positive all the time except at 0 where it's 0. Now for x minus 1, if we let x be negative, then x minus 1 is negative. You subtract 1 from a negative number, you're still negative. Likewise, if x is less than 1, let's say 1/2, when we subtract 1, we'll get a negative number. We'll get negative 1/2. But once x is greater than 1, we're going to get a positive number. Okay? So when we are looking at the entire function, we're looking at a negative times a negative. That's a negative. A negative times a negative. That's a negative again. And then a positive times a positive. And that's a positive. So our entire function, we're interested in when this guy is less than or equal to 0. So we're looking at the two minus signs. So we're going to go from negative infinity to 0, closed because we have inequality, union 0 to 1, closed, not open, sorry about that. And of course, this is a really silly way of writing the interval from negative infinity to 1, closed. So this is the best way to write your answer.